Perfect. Welcome. Thank you very much for having the opportunity to present our project RHC-ETIP here. RHC-ETIP is a project that we performed in the context of IEA DHC Annex 14, and the long title is How to Cover Peak Heat Loads in District Heating Networks with Renewables. Here is a short agenda for the next 25 minutes. I will start with a brief motivation and introduction to the project. Then Anna will talk about the options to decarbonize peak heat loads, and then I will be back again and present on the survey among district heating operators and district heating experts and what we found out there. Okay, for a brief introduction to the project. We know that many district heating networks already have incorporated CO2 neutral alternatives. Nevertheless, especially when you talk about decarbonization, it always seems like the focus is especially on the base load, while the rest is covered by gas. So we had more or less two hypotheses, and one was that this is addressing peak heat loads is a major challenge for district heating networks because on the one hand, today they still primarily rely on fossil gas and oil, and on the other hand, it is about peak heat load capacity, which means that it's not for a large quantity of heat that is produced, but on the other hand, a large capacity that must be provided to really fulfill the heating requirements. And so RHC-ETIP aims to explore the status today on the one hand and really derive what options are available for future peak heat load provision. So we have put up some hypotheses in the beginning, and these are also derived from a previous project that we have run, and they found, so to say, their way into the proposal. And one hypothesis is that peak heat load lacks a precise definition, that peak heat loads are currently mainly provided by fossil technologies. Net zero provision of peak heat loads is not yet in the focus of district heating networks, and green gas is in the focus using the same technological basis, so green gas boilers then. What did we do, and what will you see in the following is the following methods and contents. We tried to analyze the definitions and the taxonomy of peak heat loads. We looked at the options to provide peak heat loads. That is what Anna will present, including the technical and economic feasibility. And then we identify the status of peak heat loads and the expectations towards the transition in direction of net zero from the survey that we performed. This is done by the best project team suited for that, and this is Energieinstitut at Johannes Kepler University in Linz, Tallinn University of Technology, Taltech, and Euroheat and Power as a dissemination and promotion partner. The project is funded by IEA DHC within this Annex 14 call for proposals and runs since November 2023 and should come to an end rather soon in the next month. And herewith I hand over to Anna, please.
Yes, thank you. I will share my continuation of presentation. Just a moment. Yes. Just a moment. Do you see it now, or you see my screen? You see Teams?
We see the Teams.
Okay. Just a moment. This way. You should see screen.
Perfect.
Yes. Yes. But I will look a little bit to another direction now. Dear colleagues, I'm very glad to participate in this meeting, and we'll continue with the presentation of results of our RHC project. And our task as a partners were to develop taxonomy of peak heat load. And when we started to work with this topic, with peak heat load of district heating, we understood, and before we understand that actually this topic is not so simple, and many complex and both definition and classification is needed to be analyzed, and that's why taxonomy as a method has been used to make this review analysis. And the results of this taxonomy, here you see a QR code which can be used, and link which will be shared with presentation, where you will get link to taxonomy in Kumu environment, and each of these taxonomy units you can push on it and get more additional information. Like description and references to get more information about it. But in briefly, I will introduce taxonomy now. So we started with definitions, and if you would speak with any district heating expert and ask what peak heat load means, so first that an expert will start drawing in air on paper. So for sure, one of possibility to define district heating is graphical definition, and here you can see examples. For sure, text definition as maximum heat demand during specific period, and another way of presenting what peak heat load means is with mathematical approaches using equations. So the main part of taxonomy is categorization or classification, and we use classification and categorization by duration. So how long is time when peak heat load when we have peak heat load in district heating network? It can be daily or seasonal peak heat load. How frequent peak heat load occurs. Another criteria for categorization is size of peak heat load, both if we look on share of peak heat load in district heating system, and another possibility to look on size of district heating network. Small, medium, and large, and depending on need, peak heat load profile can be different. And for sure, profile, a form of profile for whole heat load duration curve, for sure influence peak heat load profile, and it is different depending on efficiency of energy efficiency of district heating network and energy efficiency of consumers which are connected to this district heating network. So what we added to taxonomy was shaving technologies, including demand side management, thermal energy storage, and impacting factors, and which for sure are related to forecasting of heat demand during all the year, but extremely important when we analyze peak heat load. And these can be found in our taxonomy. And the main conclusion, which is related to after we made this analysis using taxonomy of peak heat load, that this district heating peak heat load has been analyzed from different sides, and we identified widely used technologies, mostly fossil fuel, as Simon mentioned, fossil fuel based, peak heat load covering generation technologies, and future potential technologies that can be used to cover peak heat load demand. And as I mentioned, the impacting factors and shaving technologies have been analyzed. And based on it, the possibilities for some equipment is moving here. Based on this, the possibilities for decarbonization of peak heat load have been identified, and about it in next slide. So there are main two options to decarbonize peak heat load. One of it, which is discussed a lot, it is peak heat load management, including heat demand management and thermal energy storages, both local and large-scale thermal energy storages, and synergy with individual heating solutions, which are often now added to our consumers. And another one option to decarbonize, and actually it was the focus of this project, is optimization of peak heat load covering technologies. So from economical point of view, when it is okay to have lower capital costs, but higher operation costs, yes, comparing to base heat load covering technologies, when it is preferable that operation costs should be lower. And key parameters for technologies selection are CO2 neutrality, fast start capability, required size or area or volume or deepness, if we speak of borehole, and minimum heat load for some technologies are critical when we determine suitable peak heat load covering technologies. And the key technologies which have been analyzed in during our projects are electric boilers, heat pumps, and thermal energy storage technologies. And we used, speaking about our technical analysis, so based on categorization, which I have mentioned before, we made the analysis for 4 types of district heating network peak heat loads. So it means that are groups by size, large and small, and temperature or energy efficient. So high temperature, which is low energy efficient district heating, like existing traditional district heating network, and low temperature, more energy efficient district heating network. And for these 4 types of peak heat load, we have made 3 scenarios. When peak heat load is 10% of maximum capacity, 20% and 40%. And these here you can see these type of scenarios, and we made the analysis for 3 technologies, which I mentioned before: electric boilers, heat pumps, biomass boilers. Yes, additionally, sorry, I didn't mention it, yes, but we did it. And as a reference technology, gas boiler has been used. And the main indicators for comparing was energy saving and emission reduction. And here you can see these 4 heat load curves according these 4 scenarios for large scale high temperature, large scale low temperature, small scale high temperature, and here, sorry, mistake, and large scale low temperature. And depending on this type of heat load curve and percent of maximum heat demand, the main difference is the peak heat load hours when we have this peak heat load. And here you can see these hours, what is the difference in it. And according to performance evaluation, primary energy consumption, from one side, heat pumps show like the best efficiency and lower CO2 emissions comparing with other technologies. But here you can see comparing according primary energy efficient and for different types of scenarios. And speaking about economic evaluation, so like mostly used method as levelized cost of heat has been used, and fuel costs were analyzed, were sourced from different European and regional data, and two types of peak heat load was assumed, a little bit another approach. So for 10 megawatts and 100 megawatts capacity based on survey data, which Simon will speak later. And we didn't take into account here land area and CO2 taxes. And here you can see economic evaluation of feasible solutions or feasible options, but you can see that two types of graphs for each technology. And here we have wood chip boiler, wood pellet boiler, heat pump, electric boiler, and gas boiler, but with green hydrogen. But here data for investment, which are the most important for this case, have been taken from a Danish Energy Agency catalog and from Austrian catalog of energy technologies. And you can see here, so here are presented for three types of length, three types of time when peak heat load occur.
When it's 50 hours,
yes.
It means that we have a 10 megawatt situation and a 100 megawatt situation. And of course, if the LCOH are divided on a kind of 1,000 hours per year, the relevance of the capital costs per kilowatt hour is decreasing, and therefore the lower light area is the costs for the 50-hour situation, and the upper other way around.
Vice versa.
Other way around. The 15-hour situation is the upper darker area, and the light area is the 1,000-hour situation.
So when we have shorter time, it means that it is extremely expensive levelized cost of heat for biomass boiler and for wood pellets. But electric boilers and gas boilers is better solution for this time. But when we have longer time of peak heat load, in this case, biomass wood chips and biomass wood pellets are a better solution. And heat pumps have higher costs comparing with gas boiler and electric boiler for shorter time, and comparing with biomass wood chips and biomass wood pellets for a longer time. So I'm sorry for inconvenience a little bit, yes, because more on technique and a little bit less on economic. So thank you very much. And please, Simon, now you are back with your presentation.
Yes, I share my slides again. And you should see my slides again. Okay, I'm back.
Yes,
perfect, thank you. So part 3 is the results of the survey that we did among district heating operators and district heating networks experts. And here is the methods that we applied. So first, we had an early version of the questionnaire, which was drastically refined based on the feedback from the experts in some feedback loops, and also within the consortium. And we tried to reach two types of respondents. On the one hand, we tried to reach district heating networks, which is an important differentiation because it's not the operators, but if an operator operates more than one network, he or she was very welcome to answer the questions for different networks. And on the other hand, we wanted to have the feedback from district heating experts. And for both situations, we used a mix of closed and open-ended questions, together on the one hand qualitative but also quantitative insights. We ran the survey in spring, and so to say March to June approximately 2024. It was an online survey promoted internationally, especially from our dissemination partner Euroheat and Power, and in total we received 163 responses, and after data cleaning we had 153 valid responses, where 70 come from district heating operators and 83 come from district heating experts. There is probably one important limitation that needs to be mentioned, or two limitations that need to be mentioned. One is a limited statistical significance, so 70 responses is not too much, and especially when there are, so to say, some responses that do not occur too often, like when there's waste incineration in 3 cases, something like that. The sample is probably not big enough to have a statistical significance. And another thing is that there was a high share of responses from smaller Austrian district heating operators, which I would approximate with approximately 20% of the responses, and that means that there could be a bias towards especially biomass and of course especially regarding boiler answers. So here's some descriptive analysis, and I think there are some insights that are really interesting for statistical reference if one would need that. We have district heating networks answers from a demand that starts with 600 megawatt hours per year up to 6,000 gigawatt hours per year, so a scaling of 10,000. The median network supplies 65 gigawatt hours per year. We see that more or less all the district heating networks supply space heating and hot water, which is important to understand that it is the buildings and the behavior that impact the demand, and not maybe some kind of base load process heat demand. We see that the minimum summer demand is approximately 10% of maximum winter demand, varying only a little around that value. And supply temperatures are approximately 100 degrees Celsius in the mean, and average return temperature of 55 degrees Celsius in the mean. Again, be aware of maybe a small bias here by Austrian biomass networks. We especially see looking, for example, for the Danish responses that temperatures are lower than that. 60% of responding district heating networks have a central storage, and we see that the larger the network is, the more likely it is to have a storage. But on the other hand, the larger the network is, the smaller is the relative size of the storage. So when it is bigger, the storage size does not increase at the same level. We see that peak heat loads are predominantly covered by fossil fuels. We see that this hypothesis is proven. On the figure you can see the answers. There was more than one choice possible, but especially when you are aware that there are combinations possible, it definitely means that definitely in most cases fossil fuel fired boilers are the basis for providing peak heat loads. Thermal energy storage and preheating the network are very common measures and are often mentioned also in the additional comments from the responses. Then there is also another important finding. We see that district heating operators and district heating experts equally define peak heat loads to be the peak demand in a certain period or the load exceeding a certain threshold. So we see that the definition is more or less shared into the two groups, and definition is not unambiguous. It's yes, depending on situations, so to say, and that it depends very much on yes, what you are probably currently talking about. And we also asked where do the peak heat loads come from, and we see that daily peaks are important, like it is winter mornings especially and winter evenings, but also the coldest season in winter, which are some days or weeks, are another source of peak heat load demand. So there are also two types of peak heat loads, which is a demand that occurs for some hours and another demand that occurs for some days and weeks. And given this diversity of peak heat load definitions, also the district heating network responses range from 10 hours peak heat load per year to 1,250 hours per year, with a median of 200 hours and a mean of 350 hours of peak heat load. But that definitely also makes a big difference, especially when we talk about the choice how to cover peak heat loads ideally and what option to choose, because when you have 10 hours, the answer is probably different from the situation when you have 1,250 hours. What do the district heating operators perceive as the optimal choice for their specific networks? Here again, multiple choices were allowed, and therefore also combinations were allowed. And you can clearly see that there is a really wide distribution of technologies. So there are some that are definitely answered more often, more regularly than others. But on the other hand, a clear winner is not really visible there. This means that we have a wide distribution of technologies and a high share of responses that combine technologies. Combining technologies means, on the one hand, to not rely on one energy carrier, for example, but also with means regarding so to say, lower peak load hours and higher peak load hours to cover them with two distinctive technologies. Thermal energy storage is the most mentioned option and is more or less exclusively occurring in combination. And the most often mentioned combination is together with heat pumps. When it is about units that really generate heat, it's electric boilers, heat pumps, biomass boilers, and green gas boilers, and not too far behind also biofuel boilers, which should be responsible for achieving peak heat loads. We see and we asked if the district heating networks have a strategy to achieve net zero emissions. And we see that 50% of the district heating networks do have some kind of strategy which was not defined more narrowly. So if it is a roadmap or strategy, a plan or something like that. We see that there is no correlation with the size of the network. So it is not true that bigger networks are more likely to have a strategy. And we see also that some 86% of the strategies do include peak heat load provisions. So we need to reject the hypothesis that peak heat load is not in the focus of district heating network operators. What are the advantages of the choice you made as a district heating network operator was another question. And what are the advantages? What are the disadvantages? And here are the interpretations. So any choice is an expensive investment regarding especially the volume of energy. The CapEx capital expenditures remain the challenge of peak heat loads. They are the most important barrier. OpEx, especially the price of the energy, is allowed for peak heat loads as it runs only a few hours per year, but still this is some very expensive thing. And what we also see, and what is probably most important, when strategies are defined today, district heating operators select existing and proven technologies, not something that it is expected to happen, so to say. So district heating experts tend to believe in future developments much more in contrast to the district heating operators. So they refer much more often to, for example, green gas or demand side management. We've also asked, as you all know, heat pumps and CHP are probably a more energy or exergy efficient choice than the boilers solution. And we asked what the experts expect to be chosen in the future. And 2/3 of the experts chose the boiler technology, with the primary reason provided that the investment costs are not or are too high given the number of full load hours. And so we here are at the conclusions. And we see that the definition of peak heat loads in district heating networks remain intangible. We do not propose a separate or new definition, but we see or note that we must be aware of what we are currently talking about. Is it a short-term peak heat load? Is it a weekly, daily peak heat load? And then discuss in a more focused way. In most cases today, I think this is proven, peak heat loads are provided by fossil-based units. And we see that peak heat loads are in the focus of district heating network operators' strategies and expectations for those who do not have a strategy. They rely on existing and proven technologies, which primarily is thermal energy storage, electric boilers, heat pumps, biomass boilers, and green gas and also green oil boilers, many of them, as mentioned before, in combinations with each other. So green gas boilers are clearly not the sole or dominant part of peak heat load strategies and expectations. So another hypothesis that can be rejected at that point. And we also see that hydrogen and carbon capture technologies are hardly mentioned. High investment costs are the most significant barrier for the transition of peak heat loads. As a final slide, just as a short outlook, what is coming up. You are not expected to be able to read that. It's just a teaser, so to say. The district heating operators and district heating experts delivered very valuable comments in their explanations in the survey, and we summarized these arguments in a SWOT-like matrix. And this can be used by district heating operators, policymakers, etc., to support decision making. What is the outlook? What are the next steps? We finalize the report in the next days or weeks, and then we submit it to IEA DHC, where a revision will happen, and we think that in summer 2025 the final report should be available. So in the name of the team, I thank you for listening, and I'm happy to answer any questions afterwards.